And secondly, I'm going to share desktop 2. And because I am going to, in some cases, be showing, wait, where's my pictures here? Okay, whoops. That's not what I wanted. I wanted between the two screens here. I want to put the people on the laptop screen and Fusion 360 on the 32-inch TV or whatever it is here, 37-inch. And this is kind of weird. This keeps coming up even though I'm obviously logged in. Okay, so I want to reiterate the reminder that Dallas had at the end of the session last week, which was have a smart workflow and follow it. So I kind of made a little note of what the workflow is at the beginning of a project because it's just kind of useful to do. So first thing to do in a lot of cases is to save your project. So you're defining a new project. You can pick the appropriate location and put in a title. So I'm just going to put in Canvas test in this case. And check what are the units going to be. Let's use dinosaur units this time, or archaic units, or the king's thumb, or what was it? Three barley corns in a row makes an inch. That was the original definition. Not that I'm biased to metric or anything. And besides, US and Suriname are still using dinosaur units.
Out. Go Suriname.
Suriname's like in South America, I think. It might not be them. It might be someone else. Anyways, back on topic. Then I like to create a new component. In this case, I'm going to create a cutting board. Since that seems to be one of those things we really like doing here. And what else is in my workflow? Name and store the project, set the units, create components. Now, when you create components, you can create all the components that you can think of up front, and you can also use a structure, sub-assemblies if it's relevant. For example, if I were modeling the Ortur laser, I would have a sub-assembly around the laser assembly itself, one for the X-axis module, one for the Y-axis module, for example, and then the subcomponents within that sub-assembly. So kind of like a tree structure, much like you might have a folder structure on your computer, just an organizational tool. And it's more than organizational in case of CAD because in some cases you lock components together and move them as a body once you include something called joints, which we haven't gotten to. We didn't even cover that on 420 2 weeks ago when we should have.
Yeah, I was going to bring that up. When you chose those selections of the Ortur laser, it was pretty obvious you were choosing the parts that move and the part, you know. Right,
because one of the great tools we're going to get to at some point is the ability to animate and simulate motion.
And generally,
more advanced topics. We're not getting there tonight,
right.
But
yep.
and so yeah, that's why you organize and structure in that way. The next thing we typically do is if we're going to do top-down design, we're going to come in and define some parameters. It's a good practice. You don't always have to do it. It makes there's several good reasons for using parameters. The obvious one is to force us to do top-down design ahead of time and to use expressions, use relations, equations, so that the relationships between different parameters is appropriately expressed and calculated. And then we can go back, we can make families of products, we can make changes quickly. But one of the things is I find that editing, say for example, a dimension in a sketch way back in the tree is a bit clunky in Fusion 360, more so than it is with a number of other products. And so it's very useful to use user parameters for those. But it's not a must-have. And for example, in this simple cutting board design, I'm not going to bother with it. I want to go through it a little more quickly, and I'm not expecting to come back and do a
Hey,
whole lot of
Tim,
modification.
I think I heard you say that going back in your timeline in Fusion 360 as a way of editing dimensions is kind of clunky. And I think what you were also saying was if you do have parameters set up, you just pop that up, make changes, and there's no going back in the timeline.
Correct. Yeah. So that's good clarification. Appreciate that, Travis. So yeah, what I was implying there is you can go and modify the parameters in the parameter table without having to figure out which sketch in a fairly, in a complicated product, which sketch way back there has the dimensions that you want to modify.
Got it.
And bring it up and having the whole sketch and then sorting through the sketch to find the dimension. It's just a lot easier. So real simple components, real simple parts, yeah, you can get away without using parameters, but in more complicated products and assemblies, you'll find parameters will save you time and just make your design easier to work with and modify, tweak, refine, hone, all that kind of good stuff. Polish, what other synonyms can we use there? Okay, so the first thing we wanted to do today is we wanted to look at bringing in a canvas, because that's one of the things that Fusion 360 does really nicely. That's very useful, especially from in the cases where we get ideas from various sources, and rather than reinvent everything from scratch, it's an open source world, right? So say, for example, we go to, in this case, I'm just going to go to Google, and I'm going to search on wood platters.
So, Tim, question real quick.
Sure.
When you call it a canvas, that's sort of a non-standard term, right? You
It
mean
is
any
specific.
Kind of,
Yeah, it's specific to Fusion 360 in this case. Canvas specifically means bringing in a two-dimensional image and using it as a template to trace from.
I see. Okay.
Okay, so that's
Gotcha.
the meaning of canvas within the realm of Fusion 360.
Okay.
So, going to an image search on Google is one way. There's lots of ways. You can find all kinds of cutting boards or platters in this case. And the trick, though, is remember, we're sketching in 2D. We're sketching on a flat plane. So a picture that is not in an orthogonal plane, that we're not looking straight on to the surface, is not useful as a canvas. Might be useful for getting ideas. It's not useful as a canvas. So what we need to find is an image that's in the right orientation. So here's one. This is a cutting board, essentially, or a meat serving board. And we can just go here, and is this going to let us download? Or oops, that's not what I meant to do. Let's right click on it and save image as, and it's going to come down here as a JPEG onto my computer. Now I'll go back, get rid of the browser. I'll go back to Fusion 360. And what I'm going to do is go to the Insert menu. Oops. I'm going to pull down the Insert menu to Canvas. I want to insert a canvas. And in this case, it's not in my projects folder on Fusion 360. It's on my computer itself. I'm going to go there and pull this file here. And now it's telling me to select a face. So what what plane do I want it on? I'm going to use the XY plane. And now it places it. And it gives me the ability to do a few things. So I'm going to look from a top view and look at where it's at. The important thing to me, as I mentioned to you previously, is I like to see that I like to use the origin for symmetry when available. So to me, yeah, that looks like a reasonable place for the origin. So I'm not going to move it, but I could. There's a number of things I could do here. I could do a horizontal flip if I'd rather see it this way, or a vertical flip. Vertical flip doesn't really do much. You just see the band of light wood goes from the top to the bottom. Alternately, you can use the handles to do rotations or to do movements. In fact, you know what? Let's move this guy closer to the hole in there. And I'm going to say, okay.
Hey, Tim?
Yep.
I didn't see that there was any sense of how big that image was inside the XY plane. And I'm only asking because you could scale it there, it looked like.
You could scale it. Yeah, you could scale it there, but you're right. The problem is you can't really see what's going on.
Yeah, you don't know where your starting point is.
Right.
Okay.
So I'm going to come back. I'm going to hit the fit display so that it shows me this in nicely fit into the window. And then I'm going to look under cutting board. I see I have a folder now for canvases. And if I open that, there's a canvas, there's an image, here's the image. And if I right click on it, it gives me the ability to edit and to calibrate. So the first thing I'm going to do is calibrate. And what that does is it allows me to specify what the scale is of this picture. So let's say from here to here, so the overall length, the cutting board, let's, for the sake of argument, say 14 inches.
Hey, Tim, was there a way for you to ensure that that was going to be along the x-axis, and so you weren't getting that, you weren't setting that dimension at, say, a 3-degree angle? Could you hold a restrictor key down to keep it from being anything other than parallel to the x-axis?
That's a good question. I think you probably could.
Okay, I was just curious.
Offhand, no.
Okay, because he didn't do it in the videos either, and I was just wondering if maybe it just wasn't a feature.
Yeah, because there often are features for doing things like that within Fusion 360. That's a really good question.
Okay.
I'm going to find out.
All right, cool.
Restrict scale to horizontal. Okay, I will follow up and
when you picked those points for the dimension, there was no snapping involved. You just used your eyeballs to look at the edge.
That's correct. Because it's a bitmap image. There are no vectors available to the CAD program in this case.
Okay, thanks.
Okay. Well, that made it a lot bigger, so I'm going to use my fancy fit button down here again. It's going to come back. Now, I noticed when I put it in that it wasn't entirely centered. So even though it looked like our origin was almost in the right place, let's see if we can clean that up a bit more. And so let's turn the origin on so we can see it. And then let's, wait, something's flipping back on me here. And here I can tweak it again. If, for example, the photo that went in had been off angle a little bit and I realized there was 2 or 3 degrees, you could come in and tweak the angles. But let's move the origin And the grid snap is messing with me a little bit. Oh, no, it isn't, because there is no grid snap. And I'm going to grab this arrow.
Yeah, just following on to Jim's comment, I was keep hoping that you could do a force a coincidence of some sort, but it is just a bitmap. There are no points or vectors to mess with. That canvas is nothing but mush.
Correct. Yeah, it's just a flat sheet of paper to Fusion 360.
Okay.
Okay, the great thing now that we have this is we can use this to trace.
Tim,
So,
quick
any
question.
questions before I start tracing?
Yeah, I have a quick question. You seem to be focused on putting the origin in the middle of that circle or as close as you can get it versus in the middle of the board or somewhere else. What's going on in your design head on why you're liking that spot better than, say, in the middle of the cutting board or something else? Is there anything going on that you're saying later it'll do something more?
I have a little bit of OCD about that circle.
Okay, that works.
That's it. That's honestly it.
We've just gone inside Tim's head.
And that's a scary place to go. Okay.
The question is raised is where you put it. If you are keeping symmetry or being able to mirror about an axis, so you only have to design half of the board, are you at that stage right now or thinking about putting your origin in a place where you can do those other modifications?
Right. So what's important there is that the red line here, the x-axis, is on the line of symmetry of the board. That's the important part. Where it moves in x, y really isn't that critical.
Okay.
That's very true. So what I'm going to do now that I have this is I'm going to start sketching. So I'll start a sketch and I'll use this plane. I'm going to turn the grid off because I don't think that's helping. Hold it. Come on. I thought I had the grid off, but now I'm confused why I'm still showing it. But anyways, I will instead, let me zoom out a little bit here. And I'm going to start with some lines. So I know that this is a straight line. I'm going to come up to about here, ignoring the fillet corner. And I'm going to put in 3.65. And then I'm going to make another line from here to here. And some of this, there's multiple ways to represent, to sketch, or to trace in curvatures like this. I like to use as many straight lines and arcs as I can. So here now what I'm going to do is
Question quickly, just
sure.
are you trying to create a closed surface?
Eventually, yes. So what I want to do first is I want to capture the straight lines and the definable arcs. And by that, I mean I want to create a 3-point arc here to here that pretty much captures that outside surface, and one from here to here. Okay, now I want to kind of tweak a few things here. So if I look at this line here, it's not quite where I wanted it. Let me just tweak a few things. You can be as detailed as you want to. And now that I've gotten to this point, I want to look at key dimensions and constraints. One of the constraints that's obvious to me that needs to be done is I need to make sure that the center point of this arc, oops, that's not what I wanted. I had a pre-selected something I didn't want to pre-select there. But I wanted to select the center point of the arc and the line of symmetry so that when I mirror the arc, it properly mirrors. I want actually I want this point also to be on this line. And at the other end, things moved on me a little bit. I want this guy to also be there. Oops. Something went awry as I tried to move and scroll. This point here looks like it's not quite where I want it. Okay, there's where I want it. Now I'm going to create some fillets. And I'm just going to fillet the big radiuses. Yeah, 1 inch looks good there. And I'm going to create another one here to here. Come on. So it wasn't still on my radius tool. Here to here. And that one looks like it's a bit less than 1 inch. Let's say 7/8. And this point here has moved on me a little bit, maybe. So I'm going to modify it. All my constraints and dimensions are going to stay in place.
Tim, can you zoom in a little bit for us? I know you've got a 37-inch display, but we're not, there we go, thanks.
Yeah, so you can see it's not perfectly exact here. I might tweak a few things. For example, maybe this one here should really be 3/4. It's fuzzy, but it's basically there, okay? Now if I'm gonna fit so I can see everything, I'm going to select the entities I have here. I'm going to mirror them about, about this mirror line.
So Tim, you're not worried about the drip and the drip
drip line?
Yeah, you'll
Not
catch
yet.
that later.
I'm going to get that later. Yeah, I'm going to show that because there's a couple different ways to do it. Okay, so now that's the sketch I'm good with.
Tim,
Now
I
you
have a
notice I
question.
didn't do the little fillets. I'm going to add them later.
I have a question. So you did the coincident arc and line,
Yep.
right? That was the only thing you did? And then you were able to flip it, the whole thing.
Yeah, I wanted to make sure that the endpoints of the arc and line were on the line of symmetry, and that the center of this arc, because the arc bridge is symmetry, that it was constrained also to the line of symmetry.
Okay.
Now, you notice my lines are blue, they're not fully constrained. And when you're doing stuff that you're going to be working with a lot, it's good to be fully constrained, but it's not an absolute requirement. If you're doing something quick and dirty, I don't bother. So I'm going to finish this sketch. I'm going to go back to my home view, my isometric, and then I'm going to create an extrude. So again, an extrude takes any profile and just adds depth to it in a linear direction perpendicular to the profile. So we'll extrude, we'll grab, come on. Why is it not grabbing that guy? Let's look at sketches, grab the sketch here. Is there something that's not closed? Did I miss something?
Yeah, something's not closed because you can see your sketch didn't turn color, turn solid blue or
Right. Okay, so let's go back and edit this sketch. And somewhere, and I suspect it's here. Even though I thought I had put that on the line of symmetry, I hadn't somehow. So I'm going to make these two dots coincident.
Hey, Tim, would there have been an inspection tool that could have revealed that to you?
Well, I wasn't looking to see who was talking, but as someone pointed out, you get that dark color fill in to let you know it's closed.
Where is that dark color? It was Rob
Well,
who said that.
You can't really see it at the moment because the image is there, but if you take the image, see how it's shaded?
I see. Yeah, yeah. Right. Okay.
So, and that's another thing. You can turn the canvas off and on, just like that, right?
Had you zoomed in and looked, it would have you would have seen that it wasn't on the line.
Correct. Yeah, I thought I had put a constraint to put it on the line, but I may have missed it, or it may have repeated the center point of the arc. But now it's good. Now we can extrude. It's ready to go. Let's, what's the thickness of wood we're going to use here? How about 5/8? Since we're using archaic measurement systems, we might as well use fractional numbers, right? And now we see in the solid modeling side, we also have a fillet tool. And I'm going to grab this fillet tool, and I'm going to grab these 4 edges. And then I'm going to say, let's make these 1/8" fillets. Is that enough? Maybe that's not quite enough. How about, I don't know, 3/16. Now I have the fillets I'm looking for. Now I'm going to look back on top and go, you know what? I kind of want this hole in here. So I'm going to, rather than the hole, hole is usually for more complicated, threaded holes, different geometry and holes. A simple slot through a part like this, I like to use a sketch because it gives me more freedom. So for example, let's say I decide to sketch on here. And I'm going to zoom in here where this hole is. And just because I think it's more artistic, I'm going to use an ellipse. And I'll put my center point. I'll put a point out here. And I'll put another point here. I think it looks cool. And I'm going to use a CNC router to do this. So why not use an ellipse?
So you just told us why it is your brain said you want the origin to be in the center of that hole.
It made it slightly easier. It wouldn't have had to, but yeah, it's along those lines. And now I have that. I'm going to create, let me go back to an isometric view so I can see it. I'm going to create an extrusion, and I'm going to select this profile. I'm going to go in this direction, and what I'm going to do, so that automatically it figured out it was a cut. Remember, if I'd gone this way, it would do this as a join to the same body. I'm going to go this way as a cut. But rather than put in an arbitrary extra distance, again, I'm OCD. I'm going to say go through all in that direction.
Yeah.
Because that's my design intent. And now I can turn the image off. Oops, turn the canvas off. and see my cutting board. I'll turn this origin off at the moment because I'm not really needing it anymore either. Now, what else do I? Oh, you know what I'm going to do while I'm at it? This isn't really part of today's lessons, but I'm going to go to physical material quickly just to preview this for you, and we'll cover this sometime in another lesson. There's physical material and there's appearance. I can do either one to make this look like wood. When I do physical material, I'm actually going to get material properties as well. And even though you want something harder than pine, let's just use pine for the fun of it right now, because I tried walnut earlier and it was nice, but it just made it too dark.
Was that a drag and drop operation?
And that was just a simple drag and drop under the library.
Okay.
And so now what I've done is I've given this the material properties of pine in this case, and that includes density, etc. And if I came over to my cutting board and I clicked on properties, it's going to come up and tell me the surface area, the density of 0.33 is specified for this particular material, and you can add other materials or modify them. This tells me the mass of this is 18.3 ounces. It says ounce mass because, again, in an archaic system, we say mass and it's actually weight, but I won't get too pedantic on that.
Hey, Tim, question.
Sure.
Can you change the I noticed that it looks like the orientation of the grain is kind of the wrong way. Can you change that?
That's a really good point. When we do the class on physical materials and appearances, we'll figure out if we can do that.
Okay.
I believe we can, but I'm not sure. I haven't actually done it. I haven't really fleshed that part out. Now, the next thing that's different, or the big thing that's missing here, is the drip groove, right? We got to catch all that good jus from the steak. So what we're going to do is we're going to create a swept cut. So a swept cut is when we move a profile along a path. So in this case, let's first create the path, because that's the complicated part.
Hey, Tim, what you did last week as your final version to create the bald ends of the cracker tray,
Right?
was that a swept path?
I did. The first part was a swept path, a swept cut.
Okay.
And then at the end, I did a revolve.
A revolve cut. Okay, great.
Yeah. So in this case, the whole thing's just going to be one swept cut. And what's complicated here is the path. So let's create a sketch on this surface here. And we're going to use the offset tool. And we're going to select curves, but we'll select the whole chain. And this is the chain we're going to select. We're going to come in this way. And let's say we come in 3/8. Oops, that would be minus 3/8. Now, okay, I have a couple problems with this. I can't use this as my path because, first of all, my drip line doesn't go all the way around here, my drip groove. And the other is I don't like these sharp corners here. So while I'm in this sketch, I'm going to fillet these two together, but I don't want it to be 0.15. I want it to be more like, let's see, do I want it to be a half?
Hey, Tim, when you got those corners because you went from your 3/16 inch fillet and you tightened it up as you did the inside offset, correct?
Right. So as
it's
it did the inside offset, it got smaller and smaller until it reached 0.
Got it. Okay.
And in the early days of CAD tools, the math would fail when you went on the other side.
Got it. Okay.
Now they're smart enough to figure it out. They just take it to a sharp corner.
Got it. Okay.
And if I'd gone out this way with it, you would see that radius just continue to grow.
Got it.
Just like this radius here grew.
Got it.
Okay? So, but this isn't really what I want here either, is it? So what do I want here? Well, you know what? I'm going to get rid of some features I don't need. Let's delete that, delete that, delete that. So what I'm doing is highlighting and clicking the delete key. And this guy.
Are those nodes at inflection points?
Yes, the nodes are where we're flipping between a straight line and an arc.
Okay, great, thanks.
And then what we're going to do here is we're going to go to our line/tangent arc tool. We're going to start right here. We're going to click and drag. Now it's going to make that connection, and it's tangent here, and because everything's symmetric, it's also tangent down here, even though the tangent constraint isn't there. It just works out that way. Okay, so that's actually the trajectory that I want. So I'm going to finish that sketch. Now I need the actual profile that's effectively the router bit. So I'm going to create another sketch, but I don't have a surface there to click on. What I'm going to do is turn on the origin and grab the YZ plane, right? And then over here, if I was really being OCD, I would draw my router bit in profile. But since I know I'm just using the ball end of the bottom of a router bit, I'll cheat like I did last week and just use a circle. So in this case, I'm going to create a circle here, and I'm going to use some dimensions. First, the radius dimension. Let's make that, oh, I don't know, 3/8. Whoops.
How do you know it's radius and not diameter?
By default, it will put a diameter on a full circle and a radius on an arc. But if you want to, you can, let me redo this to show you. What you can do is click, go to dimension right here, right click and say drive radius or diameter here.
Ah, okay.
Right? So if I said radius, it would change that to radius.
Got it, thank you.
Yeah, you're welcome. It's a good question. Now the other dimensions I'm gonna use here is I'm gonna use an offset from there to here, but I think something was pre-selected, so it kind of confused it. So I just hit escape. Sometimes you have something pre-selected and you don't realize it. Happens all the time to me. So I'm gonna go with this offset, and let's put it over here where we can get it down out of the way. And let's say it's going to be, oh, I don't know, 1/16 inch. Oops. 1 divided by 16. That's my offset. And I'm going to say from here to the edge of the board initially, I'll put this up here. And what we said, that was going to be 3/8. Now, ironically, it doesn't have to be exactly the same as the path was there, because the profile can be offset from the path. You just have to be careful what happens when you go around tight radiuses and things like that, that you don't define something that's going to collide with itself. And what size router bit are we going to use here? 3/8 seems to be a popular number. And let's finish the sketch. Now we have the two sketches defined that we need. We have the path and the profile. So now we want to create a sweep. So a sweep can either create a solid or create a cut, can either add material or remove material by sweeping a profile along a selected path. Now there's some complications with guide rails and things like that. We're not going to get into that today. That's for down the road a little bit. But let's use this. And the first thing we're going to do, it's a single path type. We're going to select a profile. So our profile is going to be this circle. You see it's highlighted. And the path, we're going to include chain selection, is going to be along there. And since this partly interferes with the wood, it realizes it's a cut. We're not going to look at any of the other things. We're just keeping this simple. We're going to say OK. And there's our jus groove.
Voila.
And then we can always, you know, do fun things like let's add a tiny fillet here. That one might better be 1/8, etc. We could round these edges. We can do, you know, any of those kinds of things. But there it is, basically. And if we look at it from the top, whoops, let's go back to this top view. And we'll turn the origin off so we don't have to see that. We'll turn the canvas on. And you can see it pretty much fits the profile of what we had.
Hey, Tim, can you remove all the lines? I know down at the bottom you can choose to render it without all those lines. Can you
Yes.
show that's done?
Yeah, so that's a good point. I'm going to first turn off the canvas. I'm going to go back to this view here. And usually when I'm creating things, I like to have the lines shown so you can see the breaks between a flat surface and a curved surface, etc.
Yep.
Tangent lines. But as a matter of fact, under display settings, under visual style, we can say shaded, and now we see this.
All right.
And that's not a rendering, that's just simple shading view. Rendering is another kettle of fish that gets us something closer to photorealistic once we figure out how to use it, which will be another subject of a future lesson.
That doesn't have any effect on the machining that will be done with those interstices? No?
No.
Okay.
That's just a visual tool when you're looking at it, because things like these fillets are sometimes a little hard to see. So there's a number of different styles it can be shown with. You can shade it and show including the hidden edges, which are in this case are dashed, which is something, you know, an older drafting style. You would have shown things like that. You can do a wireframe only. Wireframe with visible edges only. So it's like a line drawing. Now, one thing that wasn't covered by, sorry, before I jump on to the next thing, any other questions and comments on it at this point?
Yes, Tim. You drew the profile 3/8 of an inch in from that one edge.
Yeah.
And you said it didn't matter if you were lined up with the original line, the original offset line. At this point, could you just say that instead of 3/8 of an inch in, you were 1 inch in, even though you're completely outside of the original line, and would it follow it?
It would. The only thing we got to worry about is what happens here, because if we go in an inch, this radius is going to go negative. So this was our definition of the profile, and here's where, had I put a parameter here, it would have been kind of useful. So I'm going to come in here and I'm going to say, make this 1 inch, and let's see what happens. And before I finish sketch, I'm going to save this in case it crashes on me. I'm going to say finish sketch. And you see it did it, but you got this. Oh, let's go back to shaded view. We're not used to seeing this, are we? Visual style, shaded with visible edges. And here's another thing the visible edges are good for, showing you sort of funky stuff going on here.
But Tim, I mean, in keeping with Jim's question, wouldn't we, when you drew the inside offset for the trough, for the juices, why weren't you just following that? Why did you force an offset from the edge?
Because from that point of view, I couldn't see my path.
Okay, but did you happen to choose the exact same distance in? So
I did.
Okay, I didn't realize that. So yeah, you knew where it was in, and you were just placing it in the same place. If you had been on a different view, you might have been able to say, make the center coincident with this line.
Yeah, and you may have reasons to force a slightly different offset. Like if we look at it right now, so here's the profile, and here's the path.
Yeah.
Now, one thing that's a bit magical here in Fusion 360 is it went with the nearest point to start. A lot of CAD packages, you have to specify a little more specifically. I mean, what's to say this profile meant start here as opposed to starting here?
It definitely followed the path, but at a inset greater than where the actual path was defined on the wood.
Right, yeah. So let's say if I went to 0.5, let's see what happens. So it's still there.
Still works.
It still works. Even the circle is off a little bit off the center of the path. Okay, now let's say that I had a complicated part like this and I wanted to cut it out by laser. The easy way to do laser is you create a sketch. And in this case, I like to make the sketch, sometimes I'll make the sketch offset from the actual object, so things are a little more obvious. So I'm going to start out actually by constructing an offset plane. And I'm going to offset from, I'd like to choose the XY plane and offset upwards, just so that I'm well off the part so I can look at my profile later. And now I have this plane here. I'm going to sketch on this plane. And what I'm going to do in sketching is I'm going to remember our project tool. So project will project the profile of an edge we select or edges we select onto our target plane. That's jumped off the side for some reason or other. Here, let's come back here. And I'm going to select this geometry as a body just to see what happens. When I say OK, now I want to turn off the body itself and just see the sketch. There's the sketch that was made. It includes the profile with the hole. And this sketch now is what I want to send to the laser to cut the profile, including the ellipse of the cutting board. So what I'm going to do is, that's this sketch, sketch 5. I'm going to right click on sketch 5. I'm going to say save as DXF. I'm going to give it a file name. And it's going to save this DXF, which I can then just import straight into Lightburn and go cut my profile.
So when you did that, it didn't select your
Groove.
because it just showed the path.
Yeah, it just selected the profile that it saw in that mode, because I selected the body, the entire body. There's different selections you can make to do this kind of thing, but if you make a complicated assembly in Fusion 360, you can then break it down and make one sketch using projections for each piece you need to cut out on the laser.
Tim, I guess it's obvious since this is the way you did it, but a sketch is a 2D and a projection onto a plane is 2D, and your exporting of a DXF is 2D, and a laser is a 2D. You do all of this in sketching. You don't go to body or component or anything. It's all done within the sketch layer, right?
That's correct. I mean, it can be, some of the profile could be 3D profile that you start with, but you're projecting a 2D projection of that profile onto your target plane. It's a silhouette. It's effectively a silhouette.
Yep.
In OpenSCAD, it's what I've used before. The projection ends up being, it's like a plane that you slice through your 3D model with. And in this case, if I wanted to get that that groove, I would adjust the plane to intersect with the groove. Is that how you would get this to project that groove also, or
well, there's a couple different things you could do. If we go back to and let's just wait, where are we? We didn't even finish the sketch yet. Let's turn the body back on.
If you're going to cover this in another one, that's fine.
No, it's really simple. That's why I want to do it here quickly, because it's a good question. What I would typically do here is I would just do another project. And this time I would select entities and come in and select whatever additional entities I want represented.
Okay.
And I'd say okay. And then I could also, one more time, project. And there's shortcuts here. I could be typing the letter P, but trying to, it gets harder to follow online. And oops, somehow did I capture that one? Yeah, I guess I did. So now if I turn the body off, all those lines are in my sketch. And I can still come in here and edit it. I can take any specific item I want and delete it. I can add things to the sketch at this point before I export it.
It's really moving things into the sketch. You're kind of
correct
the things to project, and once it's, yeah, cool.
Yeah, so typically we use a sketch to create 3D geometry. Project uses 3D geometry to create a sketch.
Yeah.
So it's a kind of backwards forwards thing.
So Tim, quick question. If you knew you wanted a juice groove and everything to begin with, instead of projecting the body when you first did it, could you have projected entities and then just put like a square around the whole board and hit select so that it grabbed them all at one time and projected entities?
That's an excellent question. And let's demonstrate. The reason we're demonstrating is because I think yes, but I don't actually know. I haven't done that. So I'm going to delete all the existing ones. I'm going to turn this body back on. There's a couple other sketches that we're seeing there, so I'll turn them off because they're confusing. And now I'm going to hit the letter P to get project. I'm going to say selection filter for entities. And then I'm going to do exactly what you suggest. Come on. I don't have a selection window. Why don't, maybe I can't. I can select them, but I can't do a selection box.
Is it because you had to have the finished sketch not connected from the first time, you still got the other sketch open? See up on
No, I deleted, I'm still in that sketch mode and I deleted the rest of those. But I'm going to try something different. But before I do that, I just want to point out one thing I forgot to mention earlier. Projection link. This isn't the best name, but what this means is the link is live. So if I have this unclicked and I project a sketch, and then later I change dimensions in here, that sketch doesn't update if the projection link isn't there. It's a snapshot in time. But if I collect projection link, I click on projection link, it'll make that connection and keep that connection live so that in future, if the 3D geometry that defines the projection changes, then the projection will update. So you can do it either way depending on what your intent is in making this sketch. Okay, so what I'm going to do this time, let's see, if I select everything first, I can't select everything first. So I guess the answer is no, Rob.
Well, when you were doing the left to right, you got to touch the body, don't you? You were across it completely, or like that. What happened to you? Nope, so it won't let you select it.
It's not selecting in sketch mode. It's not selecting those entities. And when I go into project mode, it allows me to select surfaces and individual entities, but it doesn't allow me to make a selection box.
No.
I would have thought it would, and it didn't. I thought that was a great idea. And I guess it would be. There's something to ask for.
I have a question for you. These sketches over here, some of them look different than the others. The icons. I'm talking about the icons.
Oh, yes.
Like, do you know what the difference is of these?
Okay, this is the timeline. Not everything's a sketch. So when you see
yeah. No, I'm talking about up above where it's under
here.
Right.
Okay.
Yeah.
So
I thought maybe it was like unsaved, saved. I don't know.
well, there's a lock on it, and why is there a lock on it? This is unused.
Well, I read somewhere that the lock only indicates that it is fully constrained.
Ah,
I saw too.
you may be right. That would make sense because these two are fully constrained. This one's fully constrained. This is the circle that's dimensioned. And then this is the projection. So it's fully constrained to the previous geometry. And these earlier sketches, I did not fully constrain. So
okay.
I think that's correct. Thanks. Thanks for the answer. That's why it's a discussion, not a class. Anything else on this guy?
Ship it.
Okay, next. So how are we doing time-wise? 7:30. So
One other thing. When you tried to drag and capture all of the entities, and it was not doing it, was it because we were on the projection plane, not on the object plane?
I don't believe so, but you know what? We could do that. Let's just delete this sketch since there's nothing in it right now. Let's create a new sketch right on this plane, and then see if we can select. All we get is the surface there. Let's see, can we select? No, we get the surface. And now let me try, I'll hit the P for project. And I still, nope, I don't think that was it.
Okay, all right, thank you.
You're welcome. Okay. Now I know there's a number of 3D printer users in the group. And so one request that came on pretty early was being able to take things from Thingiverse and bring them into Fusion 360 in preparation for 3D printing. Now, when we were hoping that we would be able to use Fusion 360 as our slicer, and it sounds like we do for a month or two, that was particularly useful. But it's still useful because there may be many times you want to modify something you see on Thingiverse, like put somebody's name on it, add some features to it, add some mounting features, take something that's intended for one purpose and use it for something else. So it's still a very, very valid approach.
Hey, Tim, if I could just make a comment on that. The workflow we all learn to use with our 3D printers when we buy them and we use them is we may start in Thingiverse, but we always take that STL and we run it through our Prusa slicer or whatever we're using. So this just allows us that customization sidestep. I mean, it's just the STL from Thingiverse into Fusion, then back out again as an STL and continuing our normal workflow. So I don't particularly feel that it's that much of a loss not being able to actually set the parameters and change the height of each layer and just change what your materials are, because frankly the Prusa software, which a lot of us use, does it extremely well, and it wasn't looking that robust inside of Fusion at this point anyway. So I think that it's just great that we have Fusion as a customizer, and,
yeah, and
I look at it from that way. I don't feel any loss at all.
Okay, good, because that's effectively what you've got, and that's a good way to summarize what its benefit is. So we're going to start a new project, and
Tim, before you start a new project with the other one that you had, it didn't disappear though. If you wanted to take that out to a CNC program, you would take that out of the whole component or body as a DXF 3D model, and then manipulate it in whatever that software package is, whether it's VCarve or Aspire or something. Is that how you would do it? Similar to what you said for the laser?
Yeah, I mean, I haven't taken a lot of stuff to. I haven't done CNC routing in wood from CAD myself.
Okay.
But my initial expectation was I would export a 3D model. Typically, in the 3D world, the step file is more popular. IGES files are popular as well. They don't have the approximation of an STL file. An STL file uses points and then makes lines and triangles from them. I thought that, I think it was Kennedy's explanation of that was particularly useful. That's why I picked that one as my favorite. Right. Even before I realized Lars was having trouble late in the game.
So, Travis, the Shipoko, Shipoko, I think it is. What does it use for a path generator, a toolpath generator? Because that's what you would want to send to your toolpath generator. What type of model does it want?
So without derailing Tim too much, Shipoko, the CNC that we do training on, folks, for those of you who don't know, is it has the option of coming with software that's called Carbide Create. And Carbide Create will import, for instance, an STL or, excuse me, an SVG or a DXF. And those are two-dimensional drawings, which then you'd use inside of Carbide Create to define the rest of your project and then to assign tool paths. And it's out of there you generate your G code.
It can't take the step file? Cannot?
I don't know. I don't remember it saying imported step. I do remember that it does not STL, SVG and
two-dimensional files.
Yeah, so those are all 2D.
Yeah, exactly.
Two-dimensional only, I believe.
Say that again, please.
Like that too.
One more time, Dallas.
Yeah, two-dimensional files, what you got to bring into Carbide.
Right, because it does not do anything 3D. You have to go up to their Carbide Create Pro, which costs money, or you use their Meshcam, which is another package, but very much specializes in 3D. So it's understandable that you'd only have two-dimensional files imported into Carbide Create, since that's the only output that you get out of it from your design options.
Yeah, we were hoping that what Mark showed us 2 weeks ago would be what we could do, and we can generate G-code, but it sounds like that tool is not available to us in the long run.
Right.
We need to experiment with that a little bit more.
Can you generate or can you export 360 models into Aspire and do your tool pathing there?
Sure. The Aspire is very, very impressive. Rob, you're the one who most recently purchased it as of the last few days. Do you happen to know all the import formats?
Well, I have it open. I had it open because you guys, we were talking about this. It says 3D clip art files, STL files, vector 3D model files, Rhino, SketchUp, ArtCam, 3D Studio, DirectX, DXF, Lightwave, VRML, and Wavefront.
Okay. There are no real challenges that it can't swallow, it sounds like.
Yeah, I'm surprised it doesn't take step files, but yeah, we have options. So here's what we can easily export.
There we go, yeah.
From Fusion 360. So Fusion 360 has its own format, which is F3D. Inventor, DWG, the old AutoCAD, DXF, drawing exchange format, also Autodesk. FBX, I don't have familiarity with. IGES is a 3D, initially surface, but also I believe some solids. OBJ, I think the 3D printer guys are familiar with. It's a little bit like STL, but includes color functionality and stuff like that. Surface
texture, yeah.
Definition. SAT files I'm not familiar with. SketchUp, you guys know more about than I do. SMT files, I don't recognize. Step files are the ones I most commonly use, but it sounds like none of the, it's a great 3D solid exchange format, but it doesn't sound like the G-code generators use it. That's what I would send to a tool maker to make steel tools for plastic injection molding. And then STL files, we all know.
So Tim, right now, out of those files opening, since I have the Aspire open here, there are at least 3 that it would accept: DXF, Object, and STL files.
Right. And I'm not sure. So I know what STL and Object files are like. I always think of DXF as a 2D format, so I'm not exactly sure. I think there is a 3D component to STL, to DXF, but I'm not sure what it really is.
Hey, Tim, something I ran across when I was, because I've been messing with this a little bit. If you fire up export from the file menu, it uses the cloud to generate your exported file. If you right click on your component and use the drop down to export, it uses the local, the actual software, you know, on your computer. It's at least an SDL.
Well, oh yeah, here's a limited selection. It has a smaller capability when you do the right click. It's only 5 file formats, and the other one was more. That's interesting.
I was manipulating a file and generating something to 3D print. So I was saving or exporting the STL, and my goodness, it took like 5 minutes or so to generate the STL because it used the cloud, their back end, to generate it. Whereas when I right clicked on the component and it has a save as STL right on the right click when on the
right, yeah, save as STL right here.
And that was like boom, instant.
Huh. That's very interesting.
So it's different.
Yeah.
So Tim, where were you going to take us next, Tim?
The next thing I was going to do was import an STL.
Okay.
So and the videos did a pretty good job of that. I don't think I'm going to add a whole lot to it, but for those who haven't seen it or have questions, as we go through it, maybe you'll come up with some questions. So let's go through the workflow. I'm learning my lesson from Dallas. I'm going to save this. I'm going to call it STL import test 1. And then I'm going to leave the units in millimeters. I'm going to create a new component, and this component is going to be my imported art, we'll call it. Parent is top, okay. I'm not putting in any parameters because this is just an imported item. And now what I'm going to do is I'm going to insert a mesh. And I'm going to come down to find a simple STL. And this is a simple STL. And I'm going to open it up. And there it is. Now, when it comes in, I have the options to move it around if its orientation isn't what I want. In this case, what I do is I check, I go, is this what I want for a top view? Yes. Okay. Is this what I want for a front view? Sure. Now, if I wanted the side to be front, for example, what I would do is I would go like this. I would go to this view and say, okay, I want this to be my front view. And now I forget where I found that. Set current view as front. And okay, now I have an STL file, but this is not a solid. This is an STL file only.
Tim, can you explain to us why it's important to get the solid? In the world of 3D printing that I work with, it's really, you work with STLs, there's an infill algorithm you use, and you end up with a solid print. Why is the step which we're going to be going through so important to get to? Why do you need the solid?
The reason you need a solid is if you're going to make modifications to the object for the purpose of changing what solids are going to be printed out, then you need a solid to make those solid modifications too.
Because you can't hack STL, you need to have something that is defined as solid to be able to bore holes in it or chop it in half or those kinds of things. Is that what...
Exactly.
Okay. Okay.
Exactly. That's exactly it. So now there's a couple of nuances here that complicate matters a little bit. One is, in order to work with meshes, you need to have meshes activated, and meshes are what's called a preview functionality in Fusion 360. So you hit your name up above, and you say Preferences, and when Preferences comes up, you go to Preview Features, and you make sure that Mesh Workspace is turned on. And if it isn't, then you add that. Now it says Mesh Workspace, and generally this is what's defined as a workspace. But it's been moved. It's not over here anymore. You don't see it at all right now because you're not, because we haven't converted this mesh yet.
You have your timeline going.
Oh, right, that's why, because we have to get rid of the, thank you. That was the other nuance. The other nuance is the modifications that we're doing to meshes, we can't keep the history. It's what's called DM, or direct modeling, in Fusion 360.
Tim.
And it's more like probably SketchUp is, where you do things, you don't go back into your timeline and make changes. So in fact,
Tim,
working with meshes, you can't even use the timeline.
Is your sense of it that on the one hand, working with STLs is still beta, and that having a timeline to be able to work with is a real luxury, and they haven't worked that into the STL workflow yet? Or is this really just the way you work with these kinds of models?
It's my impression that STL is such a it's a very basic construct which is not compatible with parametric modeling.
Okay.
Yeah, it was created 30 years ago.
Yeah, I was generating STL files in the late 80s to get stereolithography, which is basically resin print parts made as prototypes of injection molded plastics for cell phones. So yeah, it's been around over 30 years. So it's a very simple, archaic file. I'm kind of amazed that it's still being used in this space, but it's very robust once you get there. Now, it's not smooth. Everything is a flat, every surface is a flat triangle. But when you need curves, you just have a lot of them.
It's a heck of a lot easier if the file that you want or the object you want is in the native CAD program file format, because you have all the entities to work with and stuff, the planes, the faces and stuff. An STL is just a whole bunch of dots.
Yep.
That you then gotta, it's like a big chunk of clay. Now you gotta start kind of, tweaking it, as opposed to an assembly with parts that you can work with.
Yeah, that's a good analogy. And I know there's a lot of stuff on Thingiverse. I would encourage you, and actually I should add to the resources forum a number of links to places where you could go to get step files and other true 3D files, because there's a bunch of stuff out there that's very useful. So yeah, the part I had missed was we need to turn off design history. So we right click at the top level, and at the bottom of the menu it says do not capture design history. And when we do that, you'll notice the timeline down here is going to go away. So we say continue. Now the timeline goes away. And notice up here, we have now a mesh menu available to us. That wasn't there before. So if you look through if you see the videos, mesh appeared in here once you turned off the timeline. Yeah. But in the current UI, it's up here. Okay. Now, one of the things I like to do is come down here and open this body so that I can select things here and do things as I want. Now, basically, if I look at this object and I'm in solid and I want to make changes to it, if I go to sketch, I can't grab any one of these surfaces to sketch onto because it's not recognized as a real object in Fusion 360 Solid Modeler. So what I have to do instead is go to, am I still in sketch now? Go to something's going on here. Let me escape from what I was doing. Finish sketch. I'm going to, I don't want that sketch. Let me delete it. That was a mistake. I'm going to select the mesh body. I'm going to right click and I'm going to change mesh to B-rep, which is a solid representation. And it's going to say, have I selected a mesh body? What's my operation? New body within the component or a new component? In this case, I'm already inside imported art, so I'll just say new body. I'll say okay. And now it converts it. And when it converts it, it changes color from that blue to this gray. Now it's a solid. Now I can do various things to it. I can pick a plane here and sketch on it. I can sketch one of my favorite ellipses here and finish sketch. And then I can create a protrusion and whoops. Let's go back to this. I screwed this up. Select this profile and go this direction. Let's say through all. Okay. And now I have an elliptical hole through my panther.
You're a cruel man.
It's for mounting it, you know.
Oh, okay.
So that workflow is import as a mesh, and then what was the second thing?
Convert. Import the mesh. Turn off design history.
Right.
And then mesh to be rep.
Okay.
Which stands for body rep. In other words, a solid.
I believe it's either body rep or B spline. I believe you're right. It's probably body representation.
Okay.
I don't remember exactly. I somewhere along the line I read it, but it didn't stick.
Got it.
So that's a simple one. Now you can do things. If you need to put it on a pedestal, you can do a protrusion from it. You can do any sort of our solid models to it. You can sketch your name on there and emboss it, raise it, however you wish.
Bevels work and things like that. That's where I've used it before.
Yeah, so this guy's very angular, you know. So for example, let's see what we can do here. Let's say we grab this edge here and we say we want to do a fillet.
Yep, got it.
There we go.
Yeah. Yep.
And if you wanted to repeat that on the other ear, what's the easiest way to do that?
Well, this guy's not symmetric, so the trick would be to select them both at the same time.
Oh, okay. There's not a, I remember someplace where you could actually just repeat it by like using hand gesture with a mouse and pulling them.
Yeah, so if you right click when you're doing something, sorry, when you right click, you get, they call it the marker menu.
Yeah.
And there's some of this is context sensitive, but repeat the last command is usually straight up. So you can just kind of go like that.
Got it. Okay, great. Thank you.
And then grab your and away you go. I haven't really pushed the marker menu much because the commands are available elsewhere, and it kind of takes away a little bit from the structure of the menus, which is something I find helpful while learning.
I agree. Yeah, thank you.
Once I've learned it, then I love all the shortcuts I can get.
Got it.
Okay, I'm going to create one more here. I think we have the time. Any questions on that? Oh, I forgot to ask also if anybody had any demos to share with the crowd today.
I don't know, but it looks like we have to get something from Nancy soon because she's fading into total blackness. Doug's not that far behind her.
Okay, so that was a fairly, even though that workflow, as Nancy pointed out, is very critical and it's a little bit clunky, it's nowhere near as clunky as when we bring in a complicated STL file. If you don't believe me, go watch Lars. So I'm going to create a new one, and this is going to be STL import test2, and I'm going to leave my settings in millimeters, and I'm going to create a new component, which I'm going to name cartoon. And now I'm in cartoon, and I'm going to insert a mesh. Same thing I did before. Now I'm remembering that I had mesh activated. Once you've activated it, you don't have to do that every time. That's just a one-time. Make sure you have the tool activated in your preferences. So I'm going to insert a mesh. And I had actually tried a Baby Yoda, and it was so big that Fusion 360 really couldn't deal with it. It was 1.5 million faces. And it could not simplify it for me. It just kept failing. So I decided instead to go with Pikachu.
Is there any heads up that when you bring in something, how many faces it has, or do you have to go through the exercise to actually find out how many?
You kind of go through the exercise to find out how many it has. I mean, you see, this has quite a lot of them as well, because this nice, smooth, or slightly speckled surface is all triangles. When we bring it in, again, we can move it around, but I'm going to check, is top what I want? Yes. Is front what I want? Sure. What I could do, there's move to ground. I could move it up or down if I wanted. You know, there's various things like that. And then here's my Pikachu. Now, if I look at the body here, let's see what it tells me about properties. It tells me right here that I have almost 500,000 faces. Okay. And the appearance and physical material didn't come from the STL file. STL file doesn't include that information. These are the defaults in Fusion 360 that are the defaults. You can change the default so that you're not using the default, you're using your own default.
But in answer to Paul's question, he was asking if there was a way to tell in advance of
importing it
to a, well, I understood him to say in advance of trying to convert it to a solid, is there a way to anticipate if you're going to hit that cap of the 50,000 triangles not? It's like, I think you just showed us that if you go to the properties of the mesh, you can find out how many faces there are.
Right.
Yeah, and I think the smoothness of something that you're bringing in automatically dictates many more faces to make it more smooth.
It's an indicator, right. Yeah.
Yeah.
Yeah, if you don't have a lot of flat surfaces and you have good resolution on smooth surfaces, then you've probably got a ton of triangles in there, facets. Okay, so let's see what happens if we, first thing we have to do again, we have this timeline down here, and this is one I always forget, and I go looking for mesh to B rep for about 3 minutes, and then either somebody sees me do that and corrects me, or I finally remember I need to say do not capture design history. I get the little warning, the timeline goes away, and now I see mesh up here, and if I right click on the mesh body, I have mesh to B rep. I say that, it's selected because I selected it here, operation new body, I say okay, and it says warning. Now I'll get this warning, sometimes it'll say warning and allow me to continue. In this case, it says warning, conversion's been aborted. It cannot do it with this many faces. So typically the way that works the best for taking this down is to instead, let me see, where is it now? I've actually got to find it. I think it's in here. Reduce the number of faces in a mesh. I'm going to say reduce. I'm going to select this mesh body, and you could select it here or here. I prefer to do it this way. Reduce type, adaptive or uniform. So adaptive means it'll use larger triangles on flat surfaces and smaller triangles where it needs it for the curvature. So that's usually what's desired. And you can change density, face count, or tolerance. I go with face count. And then in here, this number I'm led to believe needs to be under 50,000. So let's change it to say 40,000. And I'm going to say OK. And I'm going to hope that I don't have a Lars moment here. And it's
Or 2 or 3 or 4.
It's not a fast operation. When I was trying the Baby Yoda, I was having a lot of Lars moments. But
And what's your platform that you're running on? You're on a Mac, like a PowerBook or i7, i5?
It's a
amount of RAM.
Pro. It's a MacBook Pro with an i5 dual processor, so it's not terribly powerful.
Okay.
Now you
Just gives
notice.
us an idea, yeah.
Yeah. Now you notice you can see the triangles. There's clearly a lot fewer triangles, and it's fewer by a factor of about 12.
Could you zoom in for us just so we can appreciate that?
Yeah, and as a result,
There you go.
we may have lost a bit of detail. But probably not. It doesn't look like it's that bad.
No.
So now that we're down to 40, let's try this again. And again, I'm doing something wrong, aren't I?
Oh, there you are.
You're doing the mesh to B-rep now?
Yeah. Oh, I need to be in solid. That's, yeah, that was another Lars moment for me earlier in the day. It's not in the mesh menu. It's under the solid. You have to be in the solids menu, and then you get the mesh to B-rep. I've got that selected, operation new body. I'm going to say OK. This time I get the warning.
But you can proceed.
Be slow, not recommended, but it's going to let me do it. And hopefully the computer won't crash. I did this earlier, but not with Zoom running. Now, speaking of platforms to be working on, that's kind of the fun thing is how cheap a tool you can do CAD on these days. Because when I started in the CAD world, you know, you needed in the 80s, late 80s, early 90s, you needed to spend $30,000, $40,000 worth of those dollars.
Yeah, right.
Yeah. But now we're more inclined to wait now. But I'm almost done waiting on this one. So
yeah, it takes a little while. But it will convert. I believe at 40,000 it converted. I might have done 30,000 last time. But that's the step, and I wanted to show you the steps. And there's really not much more to show at this point than that anyways. So
no elliptical hole through it?
There we go. Yeah, we could, you know, we can do solid modifications to it. And that's basically what I had in mind for this part of today.
That was great.
I'm going to grab myself a beer while you guys think of questions for me.
Okay.
Okay.
A second, if you don't mind.
So is this where we have just elevator music playing in the background?
Right.
Because I have not tried any of this facet of of Fusion 360.
Having the ability to edit the mesh and do things just like, you know, adding those extra curves or closing something up or cutting something out, it's just it's nice. Because lots of times, I don't know about you guys, but lots of times you get a model and just need slight tweaking, or you want to add something to it and stuff. And I've been doing it in OpenSCAD, which is a programmer's CAD thing. And, you know, there's not a mouse clicky thing. And it has been, you know, so I went into Blender, and Blender allowed me to then start clicking edges and doing the stuff. And it's just, you know, I have to admit, having a mouse and being able to select edges and doing things like that really made things quicker and easier.
Yeah, I didn't want to get in too much of the editing because we really haven't done much with surfaces yet. But some of the other videos that, trying to remember if, did Kennedy do the one where he edited the sort of radius edge of something?
See if they come on.
Here's another modification tool called smoothing, but it has some weird effects sometimes.
The smoothing?
The smoothing tool, yeah. I played with it because it actually did work on Baby Yoda, but it did some oddball stuff. And again, it takes a little while.
Hey, Tim, while it's doing that, cheers to your class and teaching us all this stuff. Much appreciated.
Thanks. I hope people are enjoying it, and I appreciate the questions and the challenges. I think I'm trying to figure out what subjects to go to next. As we kind of discussed early on, my thoughts were let's hit enough functionality up front so that people can do some of the basic things they want to do, and then maybe we can go back and fill in between the you know, fill in the cracks with more specific detail. So one suggestion that came up today was go through the various solid features in particular and explain what each feature is and what it means, because things that we've kind of bounced by, you know, what really is a sweep? There's lofts in there, there's other solid features, and explain a little bit more what they are. I'm thinking maybe that's a subject for next week.
Yeah, that'd be great. You know, I think about how a lot of us said in the beginning, we wanted to have one tool to rule all of our digital tools. And this notion of bringing in STLs, modifying them, saving them as STLs, and then continuing our workflow sort of answers the question for 3D printing. I think we spent a little time once on CNC milling, but that's a big area, and I don't know. I guess you don't have a CNC, right, Tim?
I don't.
Maybe you could find somebody like Mark who uses. That's how he generates his G code. I mean, he uses Fusion on his Shapeoko, and maybe. I think he did a quick run through, didn't he, one time?
He did a quick run through for us 2 weeks ago, and yeah, he's the best one because he does that.
Yeah, yeah.
And he was pretty excited about it.
Yeah.
Until he discovered that the manufacturer space might go away on us.
For 3D printing, it's been there for years on Shapeoko. You know, they have these pre and post processors that they allow third parties to contribute, and I don't know that the conclusion was that for G code for CNCs it would go away, but I'm not talking with a lot of knowledge. It's just that it's been there for years and years without cost.
Okay. Is Mark on the line? Because he and I talked.
He sat for 12.5 hours in conference calls today and just couldn't join us. He had to get up and walk around.
When we talked, Travis, he said it was what I found out. It's going away. It's not going away. It's just a subscription fee.
No. But I mean, that's for 3D printing and CNC, or
just a manufacturer workspace. So if you need to go into the manufacturer workspace, that extension is going away.
Okay.
So it'll still do STLs and in the make mode where you can just go to your printer and say, this is a printer, that stuff is going to still stay there as far as we know. It's just the manufacturing extension.
Which I guess I don't really know what that means, but because I don't know that area in the software.
Yeah, Mark, that's what Mark demoed. If you go to the software and you go up to that design up there where you see in the top left corner on my screen,
yeah,
you pull that down, you see where it says manufacturer. That part is an extension that they've allowed free to get people hooked. And it was normally going to be 30 days, but they extended it because of COVID-19 to May 31st. And after May 31st, it'll be a paid extension.
Yeah, and I guess what I'm saying is I don't really know what's in the manufacturing area, but I guess you're saying that that's where both the 3D printing and the CNC
Correct.
output is?
That's correct.
Okay. Well, that's unfortunate.
So we basically just need to find an external tool like Prusa Slicer or something that can handle 3D models to generate paths.
Right. If you could export, that's why I was asking about the export. You don't have the one tool rules them all necessarily, but whoever has a CNC or a 3D printer, they're using a slicer or they're using something right now to generate G-code. You could do your modeling in here, which is all the details, and export it, and then let that generate your G-code or your.
So what are you going to generate for your Aspire?
For my Aspire, I'm trying to figure out what the best models are, but I've already imported an STL and a DXF file, and they both seem to import okay. I just need to experiment since I've just had it for a day.
Come on, man, speed it up. Speed it up.
Yeah.
That's great. The other possibility, I want to look again through the licensing requirements that Autodesk has, because they do have free licenses for startup businesses and for small companies making less than a ceiling amount. But they had some exclusions in there. So for example, I think they excluded consultants.
Well, for the manufacturing extension, they addressed that in the frequently asked questions and what Mark found out on the phone. It's not going to be for a hobbyist or small businesses. The things where you get it free, it's not going to be free. So those exclusions that we already have.
Yeah. So no luck us getting it as a nonprofit.
So far, that's what they're saying.
Does anybody know what Fusion 360 costs right now?
It's about $60 a month or $4.95 a year.
So and after a year it stops working, or?
I think it's $4.95 per year. Like one of the things about Fusion 360 is it's very online. So that project storage area is on the cloud, and some of the functionality is actually cloud-based. Now,
okay.
Sometimes that's very useful. The comment earlier that is slower when using the cloud tool on export is interesting, because, for example, if you look at Google's voice recognition, when you're offline, it's terrible. But when you're online and Google's using their cloud voice recognition engine, it's actually quite good for the most part. You might get some humorous results from time to time. My brother and I have a game surrounding using voice recognition and seeing if the other guy can guess what we're talking about. But that's usually the cloud processing works really well. I'm not quite sure why the export conversion is so slow on the cloud.
Or it's a slow upload. I mean, the bottleneck could be in the upload.
It could be, but if you've saved the file, then it's already in their cloud. So
right.
If you're over here, like this directory, these directories are all on their cloud.
Yeah.
Your project directories are all on their cloud. So that's kind of an interesting one.
And they tell you that they don't look at your drawings, but who knows?
Yeah, they might have a little AI looking at it to figure out what you're doing, to see if you're doing any work. I mean, I did one little project with it. I had already done the first version of the product in Creo, and then I pulled it in here more as an exercise in, hey, can I do this kind of thing on here? Because if I find I can, then Fusion 360 is a heck of a lot cheaper than Creo. And I'm kind of 95% retired, so I'm trying not to do that much work anyways, but the time may come when I get enough work in CAD that I would actually pay for a license.
Given all the years of CAD use that you've had and the different softwares you've used, what's your impression of Fusion 360?
As a hobbyist tool, as a free tool, I think it's impressive power. For a lot of simple things that a lot of people design, it's more than adequate. It's a good, strong tool. The fact that it's parametric, that it kind of pushes top-down design, but at the same time it has these hooks to go do direct modeling and to do things like manipulating STL models is actually pretty cool. I think Autodesk is fairly genius on this. If you get into a complicated product with a lot of components, then I don't think this is the tool. And you can quickly get into even geometry creation where you run into limitations here.
What was the Pro tool that you used that was most powerful?
So the tool that I used was called, in the early days, it's called Pro Engineer by a company called, now called PTC, which used to be called Parametric Technology Corporation. They're based in the Boston area. And they built this tool back in the 80s with a bunch of expat Russian mathematicians who were really good at this stuff. A significant number of which left PTC at one point and joined a new startup called SolidWorks. And the philosophy there was to make it more user-friendly, put it on the Windows platform. It used to be you had to be on like a Silicon Graphics workstation, Unix-based, all that kind of stuff. And SolidWorks really took off because it's a lower cost, easier to use tool. And this is like another big step in that same direction. But where SolidWorks broke down was in the very, very large assemblies. It's gotten a lot better at that, but it's still not where a Pro Engineer or CATIA or NX Unigraphics, some of those other tools. Pro Engineer, Unigraphics, CATIA, these are ones that are used in the automotive industry, the aerospace industry, where you have some very large assemblies, you have very complicated revision control on your designs, you have structural, thermal, all kinds of other simulations that get done. You do automated, repetitive design, which basically optimizes. So you optimize a part to reduce the material while increasing the strength through giving it parameters that you select some of the parameters that you allow the model, the tool to modify and run additional iterative designs to develop the most efficient design or the strongest system, or whatever, that sort of thing. That's some pretty cool.
All those packages are still around and in use?
Yes, they are. I'm out of date with where they've really gone because I haven't done that complicated design work probably since my Nokia days in like 05, 06.
When you talk about CATIA, I didn't realize that they had a graphics program like that, but SolidWorks and CATIA are both owned by Dassault Systems, which is where I work. And I've been trying to, our division is called Biovia, but SolidWorks, I was trying to get them to give me a free copy. Of course they wouldn't. It's terrible. But I didn't know CATIA had that too, so that's very interesting. I wonder if those two companies are working together in any way. I don't know.
I don't know if they are or not, because both of them were acquired by Dassault, as far as I know.
Right. Dassault just acquires companies. That's all they do.
Yeah. And CATIA is higher end. You know, CATIA is probably the default standard in Europe, in the aerospace automotive, whereas Pro Engineer is more popular in North America as an American company. And I think that from talking to people, and I haven't used CATIA or SolidWorks much, and certainly not recently, but I think people thought that they may have seen CATIA pull some UI improvements in from SolidWorks, but how much it's gone, I don't know.
Yeah.
Just to make it more user-friendly.
So Tim, I have a just an administrative issue. I found all of the recordings, if you will, on the SIG for your prior session. So I'll try to catch up, including rewatching this session after you post it. But how does the group work in terms of the next meeting?
Right now, during the time while I'm cooped up at home,
yeah,
we're doing this every week at 6:30 on Monday.
So do I need to re-register, or will I automatically get an invitation?
Travis?
Please re-register. We're just trying to keep the flow through there. We don't have a lot of repeating sessions the way Tim has been so generous with his time and giving us this insight. But we do register each time. The Zoom link that you use changes each time. So you need to register to get the right link.
Okay. And I just do that right on the website, right?
Exactly.
Okay, no problem.
So once we get to a point a little further along, maybe we'll go to every other week. We'll have to see.
We're very lucky that you're cooped up. I'm sorry, Bruce, I interrupted you.
Is there? Go ahead.
Yeah, if you've got a couple minutes, there's something that I discovered. It took me quite a bit of time online to try to figure out how to do it. I just thought people might be interested in a trick that I ran into.
Oh yeah, you want to take? You want to get the? Let me stop sharing since everyone's tired of looking at Pikachu, anyways.
Jim is almost asleep.
Okay, so have you got that?
Yep, we see your table.
So this is just a table that I built a few years ago, and I'd done it in SketchUp at that time, so I used it as an example. And what I did was I created one leg, and then I mirrored it a couple of times down here to get the other three legs.
Mm-hmm.
And the problem that I ran into was I went back and I wanted to make a change. When I first went in, I didn't have this cross brace in there, and I needed to put in the mortise onto the leg. And so for right now, let me sort of just describe what I'm doing. I went in and I wanted to create a sketch, and I'll put it on that face. And let me just put in a little, some sort of.
Bruce, did you import this as a SketchUp file? Was that the
No, I didn't. I started it from scratch.
You started this one from scratch, okay.
Yes. So let me create a little sketch for a decorative item. If I go in and where'd the sketch go? Must not be where'd the sketch go. Shoot. Yeah, let me just
click on that eyeball next to it.
Yeah, make it visible. Yeah.
That one. I don't think it's that sketch though.
Oh, okay.
I think it must be on this leg.
Okay, you have your active model is the sofa table. So go
Oh.
to activate leg 1 first.
Okay. Right.
There you go.
Okay.
Now create your sketch on there, yeah.
Okay.
Gee, Tim, it's almost like you know this package or something.
I've had too many Lars moments here, and often it's been somebody on the call who's had the presence to see what's going on. That's what's great about a group like this.
I still don't see it. Anyway, shoot, I need to find
So the
some-
long and short of it is you create a feature on the leg and it doesn't appear
Right.
in your mirrored objects.
Yeah.
Oh, I
Put
see.
in a hole here.
Oh, I see.
That's your challenge, right?
Yeah.
Oh, that's good. So
It's going in the wrong
ideally,
direction.
they would all be linked, and as you made a change to one, it would be reflected in the others. Is that what you're saying,
Right.
Bruce? Okay.
So I've just done this really weird thing here on that.
Yeah, yeah.
There is a trick to this, and it's actually pretty easy. If you click on the thing that you just did,
Yeah.
hole, you can move it in the timeline such that it's before the mirrors.
Oh, look at that.
Oh,
Way to go, man.
It's all about the timeline. It's the parent-child relationships.
Hey,
Yeah, but
And-
dragging it back earlier in time that's cool.
Back to the
I
future.
didn't realize you could do that.
So yeah, I didn't either. I was trying to do it because I was trying to add some things to each one of the legs that I kept trying to put it in. I didn't want to draw it 4 times on the 4 different legs.
So it's a
And-
cutout for the flux capacitor, right?
Yeah. But whatever it is, I did actually, if you notice, there's several sketches down here, and most of those I did after a bunch of these other things out here were done. The one thing that you have to worry about is if you go in and you try to, if you dimension them off another part than the leg itself, for instance, if I dimensioned this and placed it in relationship to the top rather than just the top of the leg, then you can only pull it back as far as the top is in the
Makes
timeline.
sense.
So again, what we call that in parametric modeling is a parent-child relationship, and the child can't enter the world before its most recent parent, okay? Now, the interesting thing is it can have a lot of parents, but
It just got weird.
you can only take the analogy so far, right?
Yeah, right.
It can have many parents, but the child must be later in the timeline than its youngest parent.
So anyway, I ran into that. I dug it out on YouTube. There was one video that I finally found after hunting a bunch of mirror things that said that was how it was. And it's obviously really simple once you know that it's there, but it was difficult to figure out what it was. So I thought other people might find it.
Yeah.
I assume that will probably also work on something that's an array of something that you could put in something later after the array and just move it before the array operation.
And the idea is that you have the flexibility to do it either way, depending on your design intent.
Right.
So you want the ability to use it. So in some CAD packages, you would define each one of those legs, or you define each component, like the leg, independently, and then assemble them into this assembly. And then when you use more of the same leg, then any changes you make are automatically going to go to all of them. Then if you want to customize one, it's a little bit more involved. And these intricacies of timeline and parent-child relationships frustrate some people because it is more complicating. It is more to learn, but it's part of the power as well.
Cool. That's great.
Cool.
So any other questions, any other show and tells? Thanks a lot for that, Bruce. That's a very timely point, I think, for this group, because we're about at the point where people can pick up with these kinds of clues. And I encourage you all, when you run across something like that, to bring it to these sessions, because this session isn't intended to just be about me giving you a video and then giving you my gospel on how I do it. It's for us to learn from each other. And then similarly, any other suggested topics coming up. Right now, I've got going through some of the features and explaining what the features are. At some point, I want to do physical materials and appearances. At some point, I want to do the rendering tool. Those two might kind of go together. Surface modeling, there's some dealing with surfaces.
How about the joints and such?
Joints, assembly, joints.
The animation.
Animations, yeah, motion, those kinds of things. Yep, that's coming up. Yeah, fire a comment in the forum if you have any specific requests beyond that, things that you're running into. It's like, hey, it would be kind of cool to learn how to do this on Fusion 360. Or if you run into problems, feel free to post them on the forum, and one or other of us can maybe provide a solution, save you some time.
Sounds good.
Very good. Thank you very much, Tim.
I have a question here.
Sure.
Okay.
As far as I understand it, based on what was said this evening, is the only reason that you have to pay for Fusion 360 is for the CAM part. Is that right?
Manufacturing.
Manufacturing, yeah.
There's other functionality that you would have to pay for as well, but that's the one that's the most relevant to us. Yes.
I was wondering if there's any way for the shop to have a sort of copy that could be shared or something like that.
Oh, there's a guy sitting in my array of people here. He's got a green shirt on. Oh wait, that would be Dallas. Maybe Dallas could think about that.
We'd have to see what the interest level is and what we could bring to and how that would work, but possibility. Because
it's been impressive.
Those things probably a short amount of time. If there was a way to sort of log in and use it and not have multiple copies going at the same time, it could be nice.
Yeah.
A shared license maybe.
Yeah.
Yep.
Yeah, that's a good question. I hadn't thought about the shared license idea, but that might be a possibility where we share a license. And if a license is $60 a month and we have 10 people sharing it, that becomes very affordable.
True.
We just have to schedule it.
Right.
Yep.
I'm not sure how Autodesk would lould at that, but we'd have to figure that out.
Like another application for PunchPass.
Yeah.
There you go.
Yeah, schedule like a time in the shop. Yeah, that would work.
Yeah, we have the design workstations already, so that's cool. Anyhow, I got to get going, Tim. But
okay, great. Thanks, Travis.
Really great. Thank you, everybody.
Thanks, everybody. We're doing it over time. Appreciate all the feedback. See you guys next week.
All right.
All right. Thanks.
Bye-bye.
Good night.
Bye.
Bye.